Hello, my name is Anne Weeldens and I'm working at the Belgian Road Research Center. There I'm in charge of different projects concerning photocatalytic materials, in which we are looking at the efficiency of materials with titanium dioxide towards air purification. In that subject we are also following different working groups where we look at the efficiency of those materials at different test methods and at different applications. I'm also working at the University of Leuven in Belgium, where I teach the course of road construction to civil engineering students. What is heterogeneous photocatalysis? So photocatalysis is two parts: photo, which means light, and catalysis, which means a catalyst present at the surface. The light can be twofold. It can be UV light, which is used up till now the most. UV light is not present inside. There you have only visible light. And there we want to focus on. Catalyst means that there is something present at the surface which starts the reaction, but which will not take part in the reaction, which will not be consumed by the reaction. This is important because it will stay on the surface and it will stay active in time. Heterogeneous means that there is a gas phase which will come to the surface, a pollutant in a gas form, will react with the surface, it will depollute, it will oxidize to less pollutant materials. So there are three important things. First is the presence of light, the presence of the catalyst and the pollutant at the surface, and then the removal of the pollutant from the surface. Which catalyst do we use? It is titanium dioxide. Titanium dioxide are there in different forms. First of all, you have the rutyl form, which is the pigment widely used in any white material. This form, unfortunately, is not active towards light. The other form, the anatase, will be activated by light, so will take the energy and form radicals to interact with pollutants. This form, anatase, is mostly not active by visible light. For that we use doped titanium, which will become active also with the visible light. So now, what is special about oxalate? Oxalate is a combination of two different types of material. So first you have the doped titanium dioxide, which will be activated by the visible light, and this is made in combination with a special binder, and this binder enhances the effect of the titanium dioxide to a large extent. So due to the presence of this binder, the efficiency of oxalate will be enormously higher than the efficiency of the normal titanium doped material. So what are the challenges for photocatalytic material? Up till now we have seen that there are three important applications or problems with the applications. First is the light source. So up till now only UV active photocatalytic materials towards air purification is used. This means that there has to be UV light present. We want to go to visible light. We want to enhance that oxalate is active and largely active in the visible light. A second problem we encountered was the relative humidity, because if the relative humidity is too high, water will take the place of the pollutant and the material will be less efficient. With the special binder and with combination with other materials, we can make a product which is water resistant and which will still be active. A third problem we encounter is the adherence of the material at the surface. So what we see is that since the titanium dioxide is active, is effective towards all types of pollutants, all types of materials, organic material is decomposed by the titanium dioxide. By using this special binder, we envelop the titanium dioxide, which makes that it's not directly in contact with the coatings. So we see that now, if we use it in paint, for example, it will be active immediately, which points at the fact that the paint will not totally envelop the material. It will keep the material inside by the binder, and the titanium dioxide will attract the light and the pollutant from the surface. A comparison between oxalate and a commercial available photocatalytic paint is made. So we tested the photocatalytic paint, which should be active even in visible light. We saw that there was a reduction in NO concentration of 2 to 5%. In the presence of UV light, this increases up till 10%. When we added the oxalate to the basic paint, so without commercial photocatalytic material in it, we got our own photocatalytic paint, which shows a decrease in NO concentration up to 90% with visible light. If we added UV light, the NO concentration was reduced up till 95, even almost 100% of the NO content. So which effect does photocatalytic materials have? Where are they used? They're used in different areas. So first of all, there's the air purification area. We have soil purification, water purification. Another important area is the self-cleaning effect. So if you use it on surfaces, they will clean themselves. Other effects are antibacterial effect, anti-algae effect, so anti-greening effect outside on wet walls. Where do we want to put focus on? First of all, we want to react against the sick building syndrome. So as we can apply it in all different types of material, organic as well as inorganic, we can apply it inside in carpets, in wallpaper, in curtains, in an unwoven tissue, so in all kind of materials used inside the house. Another application will be in chimneys, where we want to enhance the effect of the chimney. We want to start at the beginning of the chimney by depolluting the smoke and ending to large depollution at the end of the chimney. Because it is so that the light will influence, of course, the intensity of the light will influence the efficiency, starting from 0 at the bottom, but going quite quickly to good efficiency, since this product reacts from 150 visible light lux intensity. As conclusion, we can say that oxalate is a product which works enormously. It is a combination of a visible light active titanium dioxide with a special binder, which enhances the efficiency to an enormous extent, which makes it also usable indoor with visible light for air purification and for other applications inside.